Okay. So there are a couple of small items. Okay, we'll try to wrap it up on OOTS concepts today. So one of the topic yesterday we discussed about data encapsulation. Okay, so what is data encapsulation? So there are two things. One is uh, when mostly this concept is applicable in object-oriented programming. So when you are defining your classes and then because when you inherit like from one class or multiple classes, right? Sometimes you want to protect your members. So the members is nothing but your variables and also your functions or methods. So that is happened. So in general, in object-oriented notations, we have something called public. So by default, everything is public. So far, we have been using it for all the variables, whatever you define. So this is all comes under public means what context we are saying access means all this whatever topic we are talking about here in encapsulation is based on the access. Means what is the scope of the access? So you will start something with base class. So that is you can say this is your base class and then you will be inheriting from here to the next class and from here to here maybe that will keep going on. So access point of view means like when where you are creating that, let's say now I am creating a variable here. So now this is specific to this particular class. So when you inherit this class onto the derived class, depending on your requirement, whether you want to allow this all the members to be accessible to other derived classes or not. Okay. In case if you do not have any restrictions, like all the members of this class to be accessible to the next class, that is a derived class, so then it should be a public. Means by default, everything is a public. When you define normal variable, that is all public. Public means every derived class can access these variables. And then we have something called private. So private we have seen exclusively. In case you want to restrict the members, that could be method or a variable, only to use within the class. Okay, not to be available, not to be made available to derived classes. So then that is a private. So how to define private? Every member which you are creating here by giving the underscore, then you are indicating that these members are only specific to available to this particular class. Means that is a owner of the class. Let's say when I define in class A, so this can be accessed only within the class and the other side we can't access it. And last one is protected. So protected is nothing but mostly in Java and then other programming languages, protected will be there. But generally, when we say protect in Python, it is almost kind of a public only. So protected variables can be used with underscore. Okay, but only thing is, it is a notation that okay, this should not be accessed. Okay, it should be accessed. Okay, but it should not be changed. Like you should not allowed to change it. But generally, Python will not follow very strictly protected. It will follow strictly public or private only. But in other object-oriented programming, they will follow protected. Okay. But in Python, if you want to use it, you can use underscore. So generally, it is an indication that okay, you can access, but don't use it. Say for example, now let's say public. Everything what we are doing is public only. You don't need to specially do it. Now I'm going to create one class. I'm just creating one class TR since it is a encapsulation. And then I'm creating one variable. So one variable I'll create with x equal to 100. This is a normal variable, means it is purely public. The moment when you say it can be a method or it can be anything. So then I am trying to create one variable with underscore equal to 100. Okay, now also I am defining one method, define, and then I'll say print self dot x. So now you can see I have created variable x. Okay, and this is a public. And this is, it is private. So I'm using this variable within this particular class E only. Okay, M, and then I'm calling self dot underscore y. The value given is 200. So we are able to do it. Okay, now let me. That I'll, okay, I'll create. So now we have self dot, like, because since we are inheriting, okay, from E to F. So when I say self dot, you can notice all this x, I'm able to get the value because we have defined those values here. And also let me, so this time I am creating object on F, obj1 dot, I'm calling M1. So now you can see when I call this M1, if object has no attribute underscore y, means this y variable is getting protected here, means you can't access. So, but if I create object here, I'll create one more object. Object 2 I am creating, and this I am directly creating on E. And I'll say object 2 dot M. Okay, so for a moment I will comment it because we are getting that error. Now you can see both are successful. So even you can see when I call this M, where is M? This is the M. Okay, and let me put some. So you can call the private, I'm able to call this private variable within this class. But when I inherit this E class to F, okay, and then when I'm trying to do, I'm able to use this public methods members, but I am not able to. Even not only that, okay, now let me here I can also do obj. So now hope you are clear about obj2, because when you are directly using this class, you can access it. But when you are inheriting this class to other class, so others are not allowed to use it. Only because he is the owner, when I create an object here, I can use it. So others I can't use it. Say one more example. So obj2 have obj1 is created on F, and if I say obj1 dot, okay, M also I'm able. So now you can see obj1 dot m. M I am able to directly access. Okay, now private variable. Why we are calling directly M? Okay, though you have created, you can't use in F. Okay, because I can't go and then print this. I can't access them over here. But since this is available to this class indirectly, so I'm able to call this method. So this is fine. So now I am going to do one more method, def m1 of self. So this time I'm giving this method with underscore underscore m1. Sorry, already m1 is there, so I'll just give as a mp. So now, since we are not calling it, it's not a issue. So now obj1 dot, when you say you are not able to see MP, you see here it's not coming. M is coming, okay, because M1 is already there because you have created here. Sorry, M is there, but it is a public, you can see it. But underscore underscore MP is a private one. So even you can't call it. Now let me say MP. The F object has no attribute MP because it is a private one. Now, but if I create an object, uh, it's on E. I'm creating object on E directly. So this is E, and now I'm calling obj2.mp. Okay, so now when you okay, so when I have created this MP, right? Currently, so these methods, okay, whatever we have here, and then you are calling directly outside here. So now this is also getting private here. Now you can see underscore underscore class E is there. Okay, class E we have created on object 2. So this is purely of this one. And then when you try to call object2.mp, so this is a private method. Now I'm doing one more. Or I can directly say e dot. So I am creating MP1 and then e dot MP, whatever underscore underscore MP is there. So now I'll call MP1. So in all the cases, right? So directly using, you can use the method, say underscore underscore. See, previously these variables were created and then you are able to directly use it. Say now Even if I say self dot, okay. So now what is happening here? MP is a method. Now let me put one more also. obj2 dot mp, which mp underscore underscore mp. So this is the underscore underscore mp, and this is mp1. So what you can notice here, the same thing. Now we can notice this is a private and this is a public. When I call this object outside, okay, one thing for sure that, so when you derive it to f, and if you try to call them, it is not possible. That is already sure. So now even within, since these variables you are directly using here, and they are coming. Even when you create a method underscore mp, now if you try to call these objects outside, it is not allowing, but you can use within the class. So now underscore underscore mp is a private, but you can access them within this class. Okay, and then if you are able to get mp1. I'll just put it here. Just have a look at. Clearly look at, you will get something. Means what has been done here. Just I'll take a pause. Just go through everything. Okay, hope you got it now. Okay, so now we'll see one more, which is a protected one. So anything which you are giving with single underscore, so that we call as a protected one. So generally protected one in Python world, not too much of significance, because Python is a current age advanced, like a next gen programming language. It would too much of it, it knows that what is required actually from the programming point of view. But if when it comes to Java, it follow very strictly. So, but nowadays, like all the new age programming languages, they are not going too much. That is the private, okay, public, okay, that is enough. So now, even if you create anything as a protected, right? So now I'll go here. Now, okay, currently we can see X only. Now I can even right now it is not displaying. Now you can see, sorry, Z. You can directly access here. And now same statement, I'm also calling where in the derived class. Okay, now let's see. Calling protect from derived C self dot Z unexpected indent. Okay, this is the indentation. We can see though it is protected means only it is protecting not to display, because the difference is that it will not show up immediately, means it is advising not to use it. Generally protected ones you have to be while you are using the programming, you have to be little vigilant about. So this is something you should not be changing. So generally in Python world, when you are working, right, what we internally refer, private ones are strictly not allowed. We can't access in the derived one. Public one, your intention is to, maybe it can be accessed by anybody. So when it comes to protected, right, you can notice that it is not displaying when I say self dot. Even now you can see here self dot. See here, you can see in E, okay, I'm not able to see this Z here. Okay, but I can access it. I am calling him here, it should be. I can see it is coming as a normal Z. Okay, now let me run it again. So we are able to directly access it. But looking at the underscore and then private behavior, sorry, protected behavior, we have to be little vigilant about accessing them. Means generally, we have to not to change the values, because the indication is that protected. Maybe theoretically, so there is no practical restrictions of the protected one, but it is a indicative that we should not be using it little vigilant, and you should not be changing the values. Okay, but once you start, it's up to you, but how do you want to use it? But in Python, these are very clear bifurcation from the public to private. Protected ones, okay, we can logically try to restrict them to use them in a vigilant manner rather than publicly accessing, like comparing to the public, what you go and then go ahead and then start changing, right? So this changing of these values in a derived classes may be not advised to do because it is a protected one. But in Java world, so protective means even it will not allow, because here I am able to do everything here. Okay, but even when I say self dot z, I can change the value. But when you are working on Java, you can see some restrictions here, changing the values and all that. Now you can see even the value also allowed to change. So what this is concept is all comes under data encapsulation. It is something providing good access restrictions which will improve the security of your data. So what to be accessed, being accessed within your class, what not to be accessed in derived class, all this concept will be data encapsulation. Means the name itself, right? You are capsulating your code like based on your access, right? Okay, this is all you are putting in one capsule. Okay, and then you are trying to restrict. So easy way to remember. So in object oriented programming, right, we discussed about class. It is a template or a framework, as I discussed. Object is kind of a Xerox copy. And then inheritance, the name itself, you are inheriting your base classes to derived class. And then data encapsulation is nothing but you are capsulating the data, means you are completely providing the data protection and access protection by capsulating the data. You are just putting all that into one bundle. You are bundling the code and then only allowing data or code to be accessed to the derived one, and which are not to be, you are providing the restriction here, access restriction here. So encapsulation means always remember public, private, protected, and then you can explain whatever way you want to explain it. So that is one behavior. In generally in Python, public and private, you can see difference. Coding errors will get it, but in Java, public, private, protected, as soon as you define them, and it will start restricting you what to access, what not to access. But here Python is okay. Like generally, you can keep moving on. So this is one concept. Okay. And now there is another very simple concept in object oriented, that is something called polymorphism. See, the name itself, right? Polymorphism is okay, using one object in multiple ways. The simple way of understanding polymorphism is uh, using one method in multiple ways. Okay, in a way, simple. I'm just explaining about in Java, then I'll come to project. Say now I'm defining one method, M, and this method taking, okay, this is one method. You put something here. And I'm defining one more method of same name, but here I'm taking one parameter P1. Okay, using same member or object in multiple forms, multiple ways. M is a method. M here without argument, here one argument, here multiple argument. Okay, if you do same thing here now in Python, what happens? Okay, let me call. I'm just trying to call it. Now you can see I'm missing two arguments. When you do this in Python, what happens? See, finally it is ending up taking the last method only because you are overriding everything. So M method is got overridden by the next method and then last method. But whereas in Java, it will be allowing to define, okay? You can define these methods and use them separately. So M and M method, okay, P1 you can give it and P1, P2 you can give it. And then you can call in Java M, and if you don't give argument, it will be calling this one. If you give variable, let's say one variable 10, since there is only one variable, it will call this one. If I give 1 comma 2, since there are two arguments, it will call it. So this is something, the good example of polymorphism, using one method or one object in multiple ways. The same name in a simple way, you have to remember same method, okay, being or same object being used in different names. So only, and I am also using word method and object. Reason is, even when you are creating a class, okay, in the when you are creating a constructor, you can create a constructor to have one variable as an input, two variables as input. Same class, you can define multiple constructors. Means when you are defining the class, right, and you can have multiple constructors, one, two, three, and then one constructor can have one parameter, one constructor can have two, same constructor, they are all, but different arguments. So that is also polymorphism. So one object being used in multiple ways. So this concept is called polymorphism. But how do we do implement in Python? Python is a next gen, so it will simplify the developer life, right? So rather than we doing all these things, right, what we can do in Python with the same polymorphism when we can refer this way. So now I can say P1 and P2 and I can give the values P1 equal 10. Now what happens when I'm calling this method? So 1 is mandatory. Now what I can do, M I am calling of 1. Let me, so now you can see I'm calling M, okay, with one argument, okay, and here I'm calling M with two arguments. So one in one shot, you are defining one place and everything you can implement inside. So this is how you can make polymorphism in Python. So M is there, P1, okay, by giving some default values, okay, you can exclude them, okay, and then you can include them. And then anything you want to write the code inside, so based on the conditions, you can write it. So Python, if you look at, right, Python is a very simplified language, developer friendly language. And that is the reason it is focused more on the achieving your goals quickly rather than too much of breaking your head with programming syntaxes, because mostly it is used for all the ML and all that. So this is all more data centric, okay, and result oriented things it will focus on rather than you remembering so much of detailed on the programming syntaxes and everything. So if you see Java, Java is very powerful in that aspects. Everything it is strictly controlled, but you have to spend a lot of time, lot of coding you have to do, and ultimately what you achieve in Java, you can very quickly achieve in the Python. And even especially from the our focus in Python, more of the implementing the AI and ML algorithms inside. So there won't be too much of insights of how detailed you will be programming here. Okay, because your focus would be on the data and then analytics there, very in the Python. So that's why not too much of detailed syntactical programming. That's why if you look at, right, concepts are there and it is very simplified, we are using it. The same concept we use it, and certain things which we don't need, they are not made available in Python. Best example is polymorphism here. So when you are using one method in multiple ways, so rather than you defining one, two, three, okay, and it is very simply you can define one method, put these arguments here, and then try to use them inside. Okay, because one method I am calling with one argument, the one method I am calling with the two argument. Okay, but return only one place, one time. Okay, so this is how your polymorphism. Polymorphism, when you remember, always remember using multiple. Mono and poly. This is the general terminology, right? Mono means single, poly means multiple. The same method or same object you being used in multiple forms, multiple times, or multiple ways. Okay, best example is, so you're defining one, but in Java case, your definition also will be three times. M without argument, M with one argument, M with two argument. But here definition is one time only, and then here calling them is two times. If you want to add one more, let's say you can say P3 equal to some blank you can keep. Okay, let's say now I can say P3 equal to, maybe I can give some 0. Even still it works because you are given a default. And even if you want third argument also, you can give. This is how you can achieve. And the same thing is applicable for class also. When you are creating the class, the same constructor you can create with multiple. Okay, but that anyway not required. You can just have a look at here. Okay, so there is one more, something called data abstraction. So what is the data abstraction? Maybe in general terminology, right? In English word, abstract means it is just a kind of a summary kind of thing. So in object-oriented notation, when it comes to data abstraction, what we do, there is a concept called abstract class. What abstract class contains? Abstract class will only have the definitions and it will not implement the code. So later on using that, we can implement the code. It is like you put all the kind of a sketch mark you can do. Let's say not fill, you can keep everything method. Okay, I want this method. Okay, and I want this structure. All that you can define in that class. Okay, and then you can implement, you can derive that class to multiple derived classes, and then every derived class can implement code according to their requirement. So this is something achieved through decorators. So these decorators we already discussed in the method. It is, that is something kind of a abstraction only. So how we can use those decorators for the classes, like when you are defining the object oriented, right? So how we can define, we can see. Today I will just try to recap what decorators we discussed in the methods when we are talking about the method, and we can try to implement, okay, tomorrow for the classes, because it will be little confused to you. I'll just try to recap what is a decorator, and then we'll try to bring up for the classes here. Say for example, I am defining one method. So in this method, I am trying to call one inner method. So remember, this is one method. In the method, I'm assuming that I will supply one method as a argument parameter. What is INN? It is a input parameter. But what is this input parameter? This input parameter is a method. So I'm expecting this come as a method here. So now what I need to do first thing is I need to first define a method INN. So why I'm implementing this one? Okay. In order to call this method, let's say assume that I'm calling this method. So when I'm calling this method, what is required here? I required something. Let's say if I try to put 100 and then run it, okay, it'll get failure because we have a M1, okay, and in M1, what are we doing right now? Sorry, it is a M1, and then we are just trying to call this inner method. So this inner method I'm calling, I'm just saying an M100. I say int object has no callable because I'm expecting this to be a method. So because why I'm calling this method here in this is the main method. I'm planning to supply. I'm expecting one method to be supplied as an argument here, and then I'm calling this here. So by mistake, okay, if without this noticing this, if you try to call is 100, so 100 is not a method, so it is getting failed. So what is required actually? We require one method to be created first. Then I can supply that as an argument here. So I'm defining a method and then I'm calling this, I'm supplying this as an argument to here. So this is a general notation. Now to avoid this, what I can do? I'm directly saying M1, then so we get the same result here. So this is another way of implementing it. So this is something we called as a constructor, a decorator. So even this is underlying, if you look at this is also kind of a data abstraction only. Means like what are we trying to do? Maybe when you are creating a class, you'll understand very clearly. Means object decorator in object oriented programming. So what are we doing here? We have something here. Okay, I'm expecting something to come here. And then I'm trying to implement it like whatever we have inside. Using that, I'm trying to implement inner. Even I can do anything here. So whatever you have here, and then okay, now even let me say x equal to 100. And even you want to supply these values as an argument to here, you can go ahead and then because so now in the M1 we have some variables and then you want to supply as arguments to here. Okay, even when I try to because these variables are defined inside. So what is coming? X equal 100. Okay, but even what you can expect is that, so now I'll say P1, say X. See, what are we trying to do here? This is something, okay, INN is a method. So what I am trying to do, INN method is I am trying to implement here. What I want to say is, let's say P1 plus 100 divided by 2. Just example I am taking. So in the M1, okay, I just have something and then I'm supplying some values to this method. But what I want to do with this X, let's say X I am saying, okay, one more example, I'll say X, Y equal to 100. So X comma Y I am supplying it. Here I'll say, because anyway, I'm expecting two variables there, P1 and P2. Here I'll say P1 and P1 plus P2. Okay, and then I'm trying to call same thing, P1 and P2. So here I'm just saying P1 into. Line 15. Some indentation problem we have. Okay, now you look at, this is something I am giving some inputs, X equal to 100, Y equal to 100. So now later on, I'm trying to implement what I want to do with X and Y. So here in this, maybe I have one scenario where I required I need to do P1 plus P2, means addition I want to do. And in this example, the second example, I want, even I don't need to use the name as INN only. I can do it any, I can add, I can make this name as. Here I just put something here. Okay, and this I am supplying arguments to XY. Okay, and whatever I have I am supplying here. Okay, but when I supply in general, right, method you have to fix up, either you do X plus Y or X minus Y something. But here what is the additional functionality we are doing? By using this, okay, automatically these values are supplied, okay, because that is what a decorator. Now you can say P1, P2. So P1, P2 will come, and then in this call I am saying, means I am implementing what I want in later point of time. P1 plus P2, okay, and P1 into P2. And if you need one more, you can also implement one more method. So when this will be helpful? Okay, when you are working on a very large module, okay, and let's say you have 100 members working, the big project, okay, and there are few things will come as an input, and then your technical lead, will create, so these kind of pre-built, ready-made structure for you. Okay, then he will ask you, okay, okay, now what do you want to do? You can go ahead and then implement it. Say, for example, you want some data, he will supply data to you. So in one scenario, you want to insert the data. You can write a logic to insert. In one scenario, you want to delete the data. You can write a logic to delete the data. So as you have the input here and then you can start implementing it. In other way, so this will be created by your lead and then kept in protected. And then as a developer, you can use them and then keep on adding something. You can keep on adding something. So in the initial classes, we discussed it as a decorator, but actually this is one of the result of the abstraction. Abstraction means, see here, we are not, of course, we are calling it, but we are not implementing the logic here. Logic implementation we are doing in the later part. Even P1, P2, if you want to add something else also, you can go ahead and then add one more method, you can develop it. So that is the concept here. So actually, this is one of the result of the data abstraction. So how the same decorators, how we can do for the classes, we can see tomorrow. That is your abstraction. So mostly we'll close object oriented portion tomorrow and then we can decide, okay, we'll try to get into file operations. Okay, I'll stop it for now. Okay, we'll see tomorrow.